Okay, so this is our first session, and I'm using the slides from a presentation I do called "Making Sense of Other People's Code." But basically, what it's about is learning how to read code. Okay,
Cool.
so the if you have questions or comments along the way, feel free. So, in a nutshell, this is pretty much my guiding principle. I heard a speaker once say that our lives change when our habits change. So my goal here is really to help you learn new habits that can have a positive impact on your career and you become a better developer and maybe even a better person just by having better habits. So
Yes.
in 2004, Mitch McConnell or Steve McConnell, Steve McConnell, in his book Code Complete, he referenced a study from 1964 that measured how programmers spent their time in a given work week. And among the many things that they did, they spent about 14% of their time reading code and about 13% of their time writing it. And he says that he's seen nothing to indicate that those numbers have changed significantly over the years. Now, about 5 years later, Uncle Bob came out with his clean code book, and he claims that developers spend 90% of their time reading code. He didn't reference any studies, but he's a pretty smart guy. I'll let him and Steve duke it out over the details. In 2017, the IEEE published a study claiming that almost 60% of the developer's time is spent trying to understand programs as opposed to writing them. I take understand as reading. So regardless, you're going to spend at least half your time reading code. And there are dozens of books that I could recommend to help you write better code. But can you even think of one book that talks about how to read code better?
No,
So,
really.
if we spend half of our time doing this, we should probably know how to do it well and develop our skills to improve our ability to do it. And that's what we're going to talk about today. All right. So first off, um, uh, is there anything that you particularly struggle with when reading code or making that makes it difficult to learn other people's code or some unfamiliar code base? Is there anything in particular that you wrestle with? Can't think of anything now. If something comes up later, let me know. I just want to make sure that I am meeting your needs. So, okay, so um, reading code isn't the same as reading a good book. You can sit down in a comfy chair, glass of wine, enjoy flipping through a good book. You might need to remember the characters and the relationships, but unless you're reading a mystery novel or a tech document, you really don't have to pay particularly close attention. When you're reading code, you probably have a pen and paper at hand, taking notes, maybe even have a printout to scribble on. You're going to use different tools and techniques to follow the flow, and frankly, it's hard work. Now, writing, that's another thing. Both prose and code take a lot of planning and rework. In fact, Ernest Hemingway, that's his picture here, he would revise his original manuscripts over and over before he released the ultimate masterpieces that he did. And so a lot of times I'll tell people, don't think your first working solution is ready for prime time. you're not better than Hemingway. Go back and refactor your code, rewrite it. Um, so what is it that makes code hard to read? I've come up with a few ideas on my own. The first thing that makes it hard to read is someone else wrote it. And someone else may have been me a few weeks ago or a year or so ago. And I wrote it, but I must have been drunk at the time. What the heck was I thinking? Or the code has no documentation and poor variable names, and I can't figure out what it's trying to say. It's loaded with magic numbers and reused variables. That can be really confusing. The large classes always are confusing, or large method names, or I'm sorry, large methods. There's the project that I work on is a 20 some odd year old Java desktop application, and we have a number of classes that are over 10,000 lines long, and methods all over the place that are over 5,000 lines long. I mean, it's just crazy. Global variables or singletons can make things confusing, bad naming. But if you think about it, this is pretty much a list of code smells. Good code is frankly easier to read, and code that's easier to read is also easier to maintain because you understand what it's about. And so you're going to create fewer bugs working on that code. And the bottom line, though, is that we can't really write good code unless we can recognize bad code. Most of my career, I couldn't tell why some piece of code was bad. I just knew it was hard to work on, and the more I worked on it, the worse it got. And so being able to recognize code smells is really important. So, no. So why do we read code anyway? Well, first, primarily the reason we're going to be reading code is to learn how it works. We need to add a feature or fix a bug. Sometimes we'll use an open source library or something, and we want to understand how it works behind the scenes. We've got some subtle issues, so we'll start reading through the code to figure out how it works. I used to work on the Microsoft Foundation classes in C++, and I constantly was digging through the source code to figure out how to make it do the things that I needed it to do. Sometimes we'll read somebody else's code to learn a different way of doing things. A lot of times, we'll read a book that has code in it, so that say, here's a better way to code, or here's we'll read the unit tests for a project or sample code to figure out, how should I use this? And a lot of times we'll also read code for a code review to hopefully keep the bugs from getting into the project. So our reference for this presentation is this book, The Programmer's Brain, by Felina Hermans. She is a college professor in Delft, in the Netherlands. And she spent a lot of time researching how to be a better instructor, and especially for computers, teaching people how to do computer work. And so she came up with, through her research, she came up with this book to help you to maximize how your brain works. And by understanding that, how to use that to become a better programmer. All right, so this is a model of our brain and how it works. Basically, what happens is information comes into your brain and runs through this filter and is stored into short-term memory. This filter would be like whatever your life experience, the things you already know, how you're feeling that day, whatever. But it's stored in a short-term memory, and it's a very small memory space between 5 and 9 items at a time. And then it goes and moves into working memory. And from there, it's associated with something in your long-term memory. Okay. So we'll dig into this more deeply as we go along. There are 3 different ways in which code can be hard to read, right? The first is lack of knowledge. The syntax is unfamiliar. I can't understand it. This is APL, so it's quite literally all Greek to most of us. This is a comment, so this tells us what this function is doing, and even then, probably still can't read the doggone code. Another reason code can be hard to read is lack of information. I'm not familiar enough with the syntax that's in here. So I work on a team of 7, 8 developers, and none of them really understands lambdas very well. So they don't use them anywhere. And they've been out for over 10 years. And so, but a lot of people don't understand it. So this sort of code would be confusing to somebody like that. And finally, there's lack of processing power. You've got this complex algorithm, and it's hard to follow, and it has what's called a high cognitive complexity. It's just, you can't keep all of that crammed up in your brain at one time. So how do we use the brain to solve these problems? Let's look back at our diagram of the brain here. Look at your long-term memory as sort of your hard disk. Your short-term memory can be like RAM, and your working memory like a CPU. So if we use the computer model for our brain. So when we're reading code, we're effectively running the program in our head, and that's called tracing. All right. So how does our brain work when we trace through a program? Well, first, we read it into our short-term memory, and we need to consider that your short-term memory only lasts about 30 seconds, 30 seconds on the outside. And you may have heard of Miller's magic number, which is 5. We can remember 5 plus or minus 2. And actually, Felina says that with recent studies, that number is more like 4 plus or minus 2. And that may be due to our dependency on cell phones and social media. But really, we break things up into small chunks to make them easier to remember. It's like how if you have a phone number, you break it up into groups of 3 or 4 numbers at a time. So how can we improve our efficiency of our short-term memory? Okay, we're gonna have an exercise real quick. So what I'm going to do is I'm going to show you some characters very quickly, and so we'll see if you can remember them. All right, 3, 2, 1. Okay, so probably very hard to remember unless you know some Russian, and even then it's all probably just nonsense. I just grabbed some Cyrillic characters, put them up in random order. So what we've done is we've overloaded our short-term memory. We've got a bunch of symbols that we don't recognize, and we can't really do anything with that. Okay, So let's try something different, right? 3, 2, 1. Okay, now that was almost possible. In fact, if you tried to write those letters down, you would probably be surprised that you likely remember more of them than you thought you would. Um, so why is this easier? We've got some association with those symbols with something we already have in our long-term memory, okay? So hold that thought. We're going to try this one more time. 3, 2, 1. Okay, so that one was easy to remember. And I didn't even keep that up as long as I kept the other ones up. So why is that? Well, we can associate those letters with something in our long-term memory. Also, the combination of those letters is stored in our long-term memory. And that's called chunking. So when you group things together in a familiar pattern, it's called chunking. So basically, we've grouped those letters into chunks that are easy to remember. And that particular phrase is even easy to remember if you know the song. So now, before I talked about how you could remember something, you could remember those random letters more than you thought you would. That's because when we when something goes into our short-term memory, it passes through something called our sensory memory. And you can kind of think of that as an I/O bus. So when you see something quickly, like we did earlier, you have a sort of mental picture of it that's stored in a special short-term memory called iconic memory. It's sort of like a persistence of vision kind of thing, like when it's dark out and a bright light passes in front of your eyes, you see that sort of draws a line. So from this iconic memory, you can make very quick associations with what's in your long-term memory. Okay, so how can we use this? Well, if you're an experienced developer, what's the first thing you do when you're looking at unfamiliar code? Well, likely you're going to first glance at the shape of the code. It's going to give you some idea of the structure and the design. So the if statement, things are indented, and you've got this switch statement. So it's going to, oops, go back. So it's going to have these cases kind of indented as well. And this little section on the right is a tool called Code Glance Pro if you use IntelliJ. It's a really handy plugin, and I use it. Through it, you can basically have a quick idea of the shape of the code that you're looking at. And so you can see, this is a bunch of nested if statements. Here's probably either a case statement or a bunch of parameters or a method call or an if statement with a bunch of and, kind of like this thing here. So, and this is probably a switch statement here. But this Code Glance Pro is a tool that makes it easy to get an idea of the shape of the code. If you're using Eclipse or VS Code, it's just a configuration setting, so you don't have to get a plugin for it. So that when you're an experienced developer, you can glance at the shape of the code and have an understanding of how it works. And an inexperienced, probably that just looks like a bunch of code. Okay, so back to our brain model. We can increase the effectiveness of our short-term memory by chunking things. So what are some ways that we can chunk the code that we read so we can understand it more quickly? Right? Probably the one thing that we think of first is design patterns, right? It's a terrific way to attach a large set of information to a single idea or word. So what we have here is our publisher subscriber pattern, or the observer design pattern. If you know how to implement it really well, you're going to recognize it when you see it in code. And you can communicate that very, very effectively. Design patterns are an excellent way to communicate complex ideas very quickly to other people who are familiar with those design patterns. I used to race sailboats, and when you're in the middle of a race and the skipper says, trim the jib sheet, that's a much more useful phrase to me instead of him saying, yeah, okay, go to the front of the boat, grab that rope and that's attached to the front sail, pull it in a little bit tighter so that it's parallel to the main sail, and then tie it off. Who has time for that? We need a quick phrase that condenses a bunch of ideas very quickly so I can do that activity. Same way, design patterns is a quick phrase that communicates a very complex idea very quickly. Documentation can be helpful. So studies show that people who are less experienced developers, they depend more on comments than more experienced developers. Why would that be? Well, probably more, excuse me, more experienced developers have learned not to trust the comments. Comments kind of get out of date. People will change the code, but they won't change the comments. But you can see here, this is a comment that explains why something works the way it works. We can also have comments that sort of section code off. It explains that this is what this particular group of code is going to do. Generally, I'll recommend that people will, instead of putting a comment there, just turn that into an appropriately named method, and then the main piece of code is easier to read. But comments like that can be really helpful. So comments like that, or a well-chosen method name, is called a beacon. The reason it's called a beacon is it helps the reader find their way through the code, similar to how a lighthouse beacon helps sailors find their way on the sea. Sailing metaphors today. The simple beacons will represent a single concept, and compound beacons will represent combinations or groups of things. So why does this matter? Well, when you're writing your code, you want to leave beacons. You want to make it easier for the next person developing code to be able to read that. Okay, so with all of this in mind, how do we use this information to address the different kinds of confusion we run into? All right, so our first problem is lack of knowledge. How do we overcome that? We research, we learn, we study, we figure out the syntax of language, we add that syntax to our long-term memory, so the next time we see this code, we can start understanding how it works. So the next time we see this or something similar, we can pick it up quickly. If we've got unfamiliar syntax, well, how do we read this more quickly? Well, you become familiar with these code structures or idioms. You practice them, you study them, you learn them, you make sure that you have that particular unfamiliar code sequence crammed away in your long-term memory so you can understand it. And finally, you've got this complex algorithm that you're overloaded with. Well, we'll talk later about how you can create an external brain extension type of thing. You can print it out, you can step through it, keep track of the variables and the calculations and that sort of thing. You might even use a debugger to facilitate this. We're going to talk about that later. I'm going to go ahead and stop here and we will continue this in our next session. So let me stop the recording.